So we'll begin Unit 9, bottom of page 1. Your task here is to use your graphing calculator to sketch the functions that are listed in numbers 1 through 3. Try to be as accurate as you can. Pay attention to the curves, pay attention to the y and x intercepts, and try to make it look exactly the same as your calculator is showing you. If you need to adjust the viewing window to be able to see things, that's fine. Just do whatever you need to be able to see the whole graph. So we'll pause here and then come back when you have those 3 graphs sketched. Okay, so we're working through pages 1 and 2 today, working on a overview essentially of polynomial behaviors, and that's what this unit is going to be about, is various characteristics of polynomials, how they play off of each other, and what the essential behaviors of them are. Homework assignment for this section is page 3, the entire thing. Okay, so starting on page 1, we need to define polynomial. First off, it's an expression or an equation that can be written as the sum or difference of terms in this format, where you have a number coefficient times a variable, usually x, raised to a whole number power. So no negative powers, no decimal powers, no fractional powers, none of that. It has to be just a regular positive whole number power. Then once you have a polynomial established, you can identify the degree of it, which would be the highest power of a variable when that polynomial is in standard form. So standard form is the polynomial written in descending order of exponents. That means largest to smallest, and those terms are going to be separated by addition or subtraction when it's in standard form. So once it's in standard form, you can look for the highest exponent, and then you'll know the degree. The other format that you'll see for polynomials is factored form. So factored form is a product where the parts are separated by multiplication rather than addition and subtraction. All right, so just a little identification exercise here. When you decide what format these polynomials on the left are in, you give either ST for standard or fact for factored. Then you can determine the degree. After you're done with that, just write a number for the degree. So pause here, try all 5 of those, and then come back. Okay, the first one is in fact in standard form because those exponents are decreasing. And notice it's missing a square. That doesn't matter. As long as the exponents that are there are decreasing, it's fine. And the degree here would be 4. So just looking for the highest exponent. Number 2 is also standard form. So you can have fractions as coefficients. You just can't have fractions as exponents. You can have negatives as coefficients, just not as exponents. So this doesn't break any of the rules. Degree is going to be 2 here because of the highest power. Format for number 3, or the third one, is standard form. It does not have to have squares or cubes or anything higher than that. It could be a first power polynomial. This one is degree 1. Number 4 is in factored form because it's in multiplication format. And so to get the degree, you want to determine what would the highest power be if you expanded it fully and then multiplied it out. So this would have an x to the 4th in front if you did all that. Therefore, it's degree 4. And the last one is also factored form, and it is also degree 4. If you look at those 4 different factors multiplied together, would give you x to the 4th. Now, if one of these factored forms had an x squared within the parentheses, that would increase the degree a little bit. So you do want to be careful with that, not just count parentheses, but each of these was degree 4. All right, this next set all break a rule. Every one of these breaks a polynomial rule. So what I'd like you to do here is figure out what went wrong with each one of these in terms of trying to write a polynomial. Write down a very brief explanation for each one. You can pause here and then come back. Okay, so the first one, you can't have an x in the power. Exponents have to be numerical. They have to be whole numbers, no negatives, no decimals. Second one, if you have an x in the denominator, you're implying a negative power. So that breaks the negative power rule. So no x's in the denominators. Third one, you can't have a root because roots are equivalent to fractional powers. So this would be like saying x to the 1/2. Fourth one's got another denominator, x, and that's no good. Last one, if you have a negative power, you're assuming a negative denominator, and so no negative powers on your x's. All right, so various characteristics of polynomials there between format, degree, and definition of. So for this set, you already did these graphs to start the work for this lesson. So let's see how you did. This one's a cubic graph. It's got a bump in it. Check your y-intercept. You should only have one x-intercept in this graph. And I've got this linear graph superimposed on it because just to show that cubic graphs behave the same at the beginning and end of their graphs as linear ones do. They're going to have a low point and a high point from one end to the other, or maybe the other direction if it's a negative in front. So linear and cubic kind of share that characteristic. Number two, the fourth power graph shares a characteristic with a square graph, a parabola, because it's got those two up arrows that you're used to seeing for a parabola. Could be two down arrows if it was negative. This has got a bump in it, so check that to see if you have the right shape. And depending on which terms and how many there are in a fourth degree polynomial, it could do that change of direction, or it could just be a narrow graph that looks like a parabola. Number three is something you should be used to. You see an upside down parabola whenever you have a negative x squared in front of a polynomial. Okay, so on to the next page. I'd like you to try the same thing with these three. So graph them carefully on your calculator. Plot them carefully on your handmade graph. It's going to take you a few minutes, so you can pause here, do these three graphs the same way you did the other three. Be careful with them, and then come on back. Okay, so number four got a lot going on. So just what I'd like you to do is check the relative positions of your x-intercepts. Is your graph crossing the x-intercept at roughly the same places you see mine? And that'll determine how carefully you copied it. Also, the height of these bumps and the depth of them on the valleys. Try to see if you did the shape correctly there. Also notice a fifth power graph does the same thing as a cube graph. It's got a lot of changes within it, but it's got that low point at the beginning and high point at the end. Linear graphs do that, cubic graphs do that, fifth power graphs do that. Okay, so number five, we have a fourth power graph, and it's got a negative in front. That's why we have down arrows instead of up arrows. Also check the shape and check how high and low your peaks and valleys go. Okay, number six is another cubic graph. It also behaves like a linear because cubic graphs will have that same end behavior. This has got a negative in front of it, and so it's starting at the top and it's ending at the bottom on a downward trend. And just check that you've got the same basic x-intercepts, the same basic y-intercept, not being terribly accurate here, but getting the right relative positions. Okay, so for the next set, numbers 8 through 10, you're going to pause again, but I'd like you to go back through graphs numbers 1, 2, 3, 4, 5, and 6. The three you did at the beginning and the three you just did here, and try to answer these questions here. So pause now and try numbers 7 through 10. All right, so number 7, you should have identified numbers 1, 2, and 4. They all have positive leading coefficients, so that's what they have in common. That's what makes them increase. Number 8, it's 3, 5, and 6. Those are the ones that decrease. They all have a negative leading coefficient. So that's what's controlling the direction of the graph. All right, so increasing to both the right and left, or decreasing to both the right and the left. What this is getting at is if you look at the left side of the grid and the right side of the grid, are those arrows both going up or are they both going down? Numbers 2, 3, and 5 do that. And those are all going to have even degrees. They're all fourth degree or second degree. So whenever it's an even power in front, your starting points and your ending points are both going to be pointing the same direction, either up, up, or down, down. And the ones that go in opposite directions are the others. The numbers 1, 4, and 6, those are your odd degrees. So to summarize that, what we can say is if both ends increase, it's going to be an up, up arrow just to indicate that. Both ends decrease, it's going to be down, down, and then we have one of each for the other two types. All right, and then we'll finish with numbers 11 through 15. If you try each of these, pause here, and then you can come back and check. All right, go ahead and check your arrows. Did you get the correct end behaviors? Did you identify the reason for them? You're looking for degree type, odd versus even. You're looking for coefficient type, positive versus negative. So you can write down the summary. Again, pause and write it down. And then you'll go to page 3 and try to identify those different behaviors. So on page 3, you're looking for the degree, which would be the highest exponent. You're looking for the lead coefficient, which is the number in front, and then identifying the end behavior. Down the bottom, you're doing the same thing. Well, you're identifying whether they're polynomials by the definition. So you're looking for all those characteristics of polynomials here.